Right now, as you sit here on Earth, the universe is buzzing with activity stranger than fiction, more mind-bending than dreams, and utterly real. Imagine colossal stars tearing themselves apart in dramatic fashion, black holes quietly swallowing entire worlds, and rogue planets drifting aimlessly through the infinite dark without a star to call home. These are not distant bedtime stories. They are events unfolding in real time, painting a picture of a cosmos far more bizarre and mysterious than we could have ever imagined. But here's the twist: hidden within these strange phenomena could be answers to some of humanity's biggest and oldest questions. Where did we come from? Are we alone? And what fate does the universe have in store for us? From enigmatic signals traveling billions of light years to galaxies breaking every rule we thought we understood, we are about to embark on a journey into 25 of the most astonishing cosmic occurrences, each pushing the boundaries of scientific knowledge and daring us to dream bigger. So, buckle up as we explore the cosmos like never before, peeling back the curtain on a universe that is as perplexing as it is awe-inspiring. Now turning to one of the most enigmatic mysteries of the cosmos, we have the phenomenon of fast radio bursts. These are extremely brief but incredibly powerful pulses of radio waves that originate from far beyond our galaxy. Each burst lasts only a fraction of a second, yet in that fleeting moment, it emits as much energy as the sun does over several days. Let that sink in for a moment, the vastness of power in just an instant. Scientists first stumbled upon these mysterious signals by accident, and to this day, their exact origins remain a puzzle. What makes them even more fascinating is the discovery of repeating fast radio bursts. Unlike one-off bursts, these seem to occur in patterns, emerging from the same source multiple times. This has sparked a wave of intrigue and countless theories. Some researchers believe they could be produced by highly magnetized neutron stars, known as magnetars, whose intense magnetic fields might generate these bursts. Others point to the chaotic environments near black holes as a possible source. And then, of course, there's the theory that captures the imagination of many. Could these be signals from an advanced extraterrestrial civilization attempting to reach out across the void? While there's no definitive answer, the detection of more of these bursts has fueled our curiosity like never before. Advanced telescopes are now working tirelessly to uncover the truth, pinpointing the locations of these emissions and studying their properties in meticulous detail. Whether they turn out to be the result of natural cosmic phenomena or something entirely unexpected, one thing is certain: they remind us of how much we still have to learn about the universe. And as we probe deeper into these fascinating signals, another mystery awaits, one that takes us to a realm where the absence of almost everything creates one of the most unsettling cosmic puzzles of all time. Moving forward, we journey into a region of the universe where the absence of almost everything creates an eerie cosmic enigma: the Boots Void. Now picture this: a vast, unimaginably empty expanse spanning approximately 330 million light-years across. This colossal cosmic desert contains far fewer galaxies than one might expect in such a volume of space, making it one of the largest known voids in the universe. For context, if our Milky Way were placed in the Boots Void, it would appear utterly isolated, with no neighboring galaxies visible for hundreds of millions of light-years in any direction. It is a silence so profound that it forces us to question what we truly know about the fabric of the cosmos. Scientists have long sought explanations for this baffling emptiness. Some suggest it is a natural result of the universe's large-scale structure, shaped by gravity pulling matter into clusters and leaving behind empty pockets like this. Yet, even by these standards, the Boots Void stands out as extraordinarily barren, defying easy categorization. Another intriguing theory posits that smaller voids may have merged over time, creating this gargantuan gap. This could mean that what we see today is the result of processes that unfolded over billions of years. To unravel its secrets, researchers are using advanced simulations and powerful telescopes, examining the sparse galaxies that do exist within the void. Surprisingly, the few galaxies found there appear unusually large and luminous, sparking further questions about how such isolated systems could evolve. Could there be unknown forces at work shaping this emptiness, or is it a glimpse into the very limits of our understanding of the universe? As we peer deeper into this cosmic abyss, one thing becomes clear. The Boot's void is not just a scar in space, it is a challenge to our understanding of how the universe organizes itself. And just as we begin to grasp the scale of this emptiness, the cosmos offers us yet another marvel to ponder, one where destruction and creation intertwine in the most spectacular way. Now shifting our gaze to one of the universe's most awe-inspiring displays, let us witness the cosmic dance of destruction, a star being consumed by a black hole. This phenomenon, known as a tidal disruption event, is as dramatic as it sounds. Imagine a star wandering too close to a black hole's immense gravitational pull. The black hole stretches and tears the star apart, sending streams of stellar material spiraling into an accretion disk, a swirling, luminous ring of gas and debris. As this material gets pulled inward, it heats to astonishing temperatures, emitting a brilliant burst of energy that can be observed from billions of light years away. Recently, telescopes have captured these events in mesmerizing detail. For instance, one such event, labeled at 2019 KIS, occurred in a galaxy nearly 215 million light-years from Earth. Astronomers observed the star's destruction in real time, watching as it unleashed enormous amounts of X-rays and ultraviolet light. This extraordinary spectacle provided valuable insights into the feeding habits of black holes and the forces at play in their vicinity. But what happens after the star is devoured? The aftermath is equally intriguing. Some of the stellar debris is pulled into the black hole, adding to its mass, while other parts are flung outward in cosmic jets, traveling at nearly the speed of light. These jets, detectable across vast distances, offer a unique opportunity to study the extreme physics of black holes, regions where the known laws of physics begin to break down. Beyond their scientific significance, these events remind us of the raw power and unpredictability of the cosmos. They highlight the delicate balance in space, the thin line between creation and annihilation. And as we marvel at these celestial fireworks, the universe continues to unveil its mysteries, one spectacular moment at a time. With the remnants of a shattered star still glowing in our minds, we now turn to an event that represents not destruction, but a cosmic explosion of unprecedented brilliance. As we delve into the next cosmic phenomenon, prepare to witness an event so powerful it defies imagination, the brightest cosmic explosion ever recorded. This extraordinary outburst, known as a gamma-ray burst, is a fleeting yet unimaginably intense surge of energy that can outshine entire galaxies in mere seconds. Gamma-ray bursts are thought to originate from the universe's most cataclysmic events, such as the collision of neutron stars or the dramatic death of a massive star collapsing into a black hole. These bursts release such immense energy that they can be detected across billions of light-years, making them some of the most luminous events ever observed. Recently, astronomers uncovered an explosion that dwarfed all previous records. This gamma-ray burst, detected in October 2022 and humorously nicknamed the Boat, or the brightest of all time, was more than 70 times brighter than any other previously witnessed. Its light traveled an astonishing 2 billion years across the cosmos before reaching our instruments. But what could produce such a monumental burst? Scientists hypothesize that this particular explosion marked the violent end of a giant star, so massive that its collapse created a black hole. As the black hole formed, it unleashed powerful jets of gamma radiation that traveled at nearly the speed of light, piercing through the remnants of the dying star and lighting up the universe like never before. This unprecedented event not only captivated astronomers but also provided valuable insights into the mechanisms behind these colossal bursts, including the composition of their jets and the environments in which they occur. Intriguingly, bursts like this might also have implications for life itself. Some theories suggest that past gamma-ray bursts in the Milky Way could have impacted Earth, potentially altering its climate or even contributing to mass extinctions. While the boat marks a turning point in our understanding of energetic cosmic events, it also leaves us with tantalizing questions. Could bursts even brighter than this one be lurking in the depths of space, waiting to reveal themselves? With this extraordinary discovery illuminating our journey, let us now shift our focus to another cosmic enigma that roams the galaxy in solitude, planets without a star to call home. Now venturing into the boundless expanse of our galaxy, we encounter a phenomenon as haunting as it is fascinating: rogue planets, the cosmic wanderers that drift through space without a star to anchor them. Unlike planets in our solar system which faithfully orbit the Sun, these lonely travelers have been cast adrift, roaming the galaxy in perpetual darkness. But how do these planets lose their stars, and what secrets might they hold? Scientists believe that rogue planets may form in much the same way as regular planets, but their fate changes drastically through gravitational interactions. Perhaps they were ejected from their original planetary systems during the chaotic early stages of star and planet formation, or perhaps the gravitational influence of a passing star tugged them free from their stellar embrace. It's also possible that some rogue planets formed in complete isolation, coalescing out of gas and dust far from the influence of any star. Recent discoveries of these celestial orphans have shed light on just how common they might be. In 2021, astronomers identified a staggering number of potential rogue planets in a nearby region of the Milky Way, with some estimates suggesting there could be billions of these starless nomads across the galaxy. For example, a rogue planet roughly the size of Earth was detected through a phenomenon called gravitational microlensing, where the planet's gravity temporarily magnifies the light of a distant star as it passes in front of it, an incredible feat of cosmic detective work. What makes these wandering worlds so intriguing is the possibility that they might harbor conditions conducive to life. While the absence of a star means no sunlight to heat their surfaces, rogue planets could still retain internal heat from their formation or from radioactive decay in their cores. If such a planet harbored subsurface oceans beneath thick layers of ice, it's conceivable that microbial life could survive in such an environment, much like organisms thrive in Earth's deep ocean hydrothermal vents. Of course, the challenges to exploring or even detecting such planets are immense. They are faint, elusive, and often shrouded in mystery. Yet the study of these solitary worlds broadens our understanding of planetary diversity and raises profound questions about the potential for life in the unlikeliest of places. As we marvel at the mysteries of these vagabond planets, let us continue our journey into the cosmos, turning our gaze to an even grander scale, the ever-accelerating expansion of the universe itself. With our next step into the cosmic unknown, we find ourselves grappling with one of the most mind-bending mysteries of all. The universe itself is expanding, and not just expanding, but doing so at an ever-accelerating pace. This discovery, first made in the late 1990s, defied expectations and overturned long-standing assumptions about how the cosmos behaves. For much of the 20th century, scientists believed that the pull of gravity would gradually slow down the universe's expansion over time. Some even thought it might eventually reverse, causing the universe to collapse in a so-called Big Crunch. But observations of distant supernova, a kind of exploding star, revealed something entirely unexpected. Instead of slowing down, the expansion of the universe is speeding up. This astonishing finding left scientists searching for answers, and what emerged is one of the most perplexing concepts in modern physics: dark energy. Dark energy is a mysterious force that is believed to be driving this accelerated expansion. but what it is and how it works remain some of the biggest unanswered questions in science. Current theories suggest that dark energy could be a property of space itself, meaning that as the universe grows, more space is created, and with it, more dark energy to fuel the acceleration. Others speculate that dark energy might be tied to the fundamental nature of gravity, or perhaps to an entirely new force that we have yet to understand. To study this enigmatic phenomenon, astronomers and physicists have turned to some of the most powerful tools ever built, from space telescopes like the Hubble to massive ground-based observatories. They are measuring the expansion rate of the universe with incredible precision, using methods like observing cosmic microwave background radiation, the faint glow left over from the Big Bang, or mapping the distribution of galaxies across billions of years of cosmic history. What they hope to uncover could transform our understanding of the universe and our place within it. And yet, the more we learn, the deeper the mystery seems to grow. If dark energy makes up roughly 70% of the universe's total content, as current estimates suggest, then we truly know very little about the majority of what exists. This conundrum reminds us of just how vast and unpredictable the cosmos truly is, a place where every answer leads to even more questions. As we ponder the profound implications of dark energy, let us press onward to another enigma of the universe: strange anomalies in the leftover light from the Big Bang itself. Stepping further into the fabric of the universe, we encounter an extraordinary relic of the cosmos' infancy, the cosmic microwave background. This faint glow of radiation, lingering from the Big Bang nearly 14 billion years ago, serves as a snapshot of the universe when it was only about 380,000 years old. A time when the first atoms began to form and light was finally able to travel freely. By studying this ancient radiation, scientists have unlocked countless secrets about the early universe, from its composition to its age. Yet, as we probe deeper into this cosmic fossil, anomalies emerge that defy our understanding. One of the most famous of these is the cold spot, a peculiar, unusually large region of the cosmic microwave background that appears significantly cooler than its surroundings. Discovered through precision measurements by space observatories like the Planck and Wilkinson microwave anisotropy probe, this mysterious cold region challenges the standard model of cosmology. Some theories suggest that the cold spot might be the result of a massive void in space, a region almost entirely devoid of galaxies that stretches across hundreds of millions of light years, causing light passing through it to lose energy. Others propose far more exotic explanations, ranging from quantum fluctuations in the early universe to speculative ideas about alternate universes briefly interacting with our own. Adding to the enigma are other smaller inconsistencies in the cosmic microwave background, such as unexpected asymmetries or subtle deviations in temperature patterns that hint at phenomena beyond our current models of physics. These anomalies raise profound questions about the very nature of the cosmos. Was the early universe truly as uniform as we believe, or are these oddities clues to something even more fundamental waiting to be uncovered? As researchers refine their tools and study these strange imprints further, the hope is that these anomalies will either confirm our existing theories or unravel new ones. Either way, the cosmic microwave background continues to be an unparalleled window into the universe's earliest moments, pushing the boundaries of human knowledge. With these cosmic imprints still puzzling the brightest minds on Earth, let us turn our gaze to yet another marvel of the universe, a pulsar with a truly bizarre and rhythmic heartbeat. Shifting our focus to a remarkable phenomenon, let us delve into the intriguing world of pulsars, rotating neutron stars that act like celestial lighthouses, emitting beams of radiation as they spin. These extraordinary objects are the remnants of massive stars that underwent a supernova explosion, leaving behind an incredibly dense core. Imagine a star no larger than a city, spinning hundreds of times per second and releasing precise, rhythmic pulses of energy. It's like the universe's most accurate clock, ticking with unwavering consistency. However, a recently discovered pulsar has stunned astronomers with a heartbeat that is anything but ordinary. This pulsar, located in a distant corner of our galaxy, displays an erratic yet captivating pattern of emissions that defies conventional understanding. Its irregular rhythm seems to mimic something more biological than mechanical, almost as if it were alive. Scientists initially believed it was a standard pulsar exhibiting occasional glitches, temporary slowdowns, or speed-ups caused by its internal structure shifting. But upon closer observation, the emissions displayed a level of complexity never before observed in such objects. What makes this discovery so compelling is the way it challenges established theories about pulsar behavior. These objects are powered by the intense magnetic fields and rapid rotations of neutron stars, yet this peculiar pulsar suggests there may be unknown dynamics at play. Could it be that we are observing some kind of interaction with an unseen companion star, or perhaps its magnetic field is behaving in ways we've never predicted? Even more intriguingly, some astronomers suggest it could be linked to exotic states of matter, forms we cannot yet recreate on Earth. This pulsar's peculiar heartbeat serves as a stark reminder that the cosmos is far more complex than we can currently comprehend. As new telescopes and detectors come online, scientists are eager to continue studying this mysterious object, hoping to decode the secrets hidden within its unique rhythm. And while this pulsar softly hums its enigmatic tune across the vastness of space, it invites us to ponder one of the universe's greatest unanswered questions. How much do we truly know about these cosmic timekeepers? With this curiosity in mind, let us journey further into the cosmos to uncover yet another celestial wonder, a supermassive black hole that appears to be on the move. Shifting our gaze to a truly extraordinary cosmic occurrence, let us uncover the mystery of a supermassive black hole that appears to be on the move. This is not just any black hole, this is an object millions or even billions of times more massive than our Sun, and yet it seems to be drifting through space, defying the usual expectation that such colossal entities remain anchored at the centers of their galaxies. The discovery of a supermassive black hole seemingly being ejected or moving unusually has left astronomers both puzzled and amazed. What could possibly dislodge something so unimaginably heavy? One prominent theory points to the powerful ripples in spacetime known as gravitational waves. These waves are produced when two massive objects such as black holes collide and merge. In some cases, if the merger is uneven, it can create a recoil effect, essentially giving the resulting black hole a mighty kick and sending it hurtling through space. Another explanation considers the possibility of galactic mergers. When two galaxies collide, their central black holes spiral toward each other, eventually merging. But during this chaotic process, the combined gravitational forces can sometimes propel one of the black holes out of its original trajectory, setting it adrift. As fascinating as these scenarios are, they raise even deeper questions about the structures we see in the universe. If a supermassive black hole is ejected from its galaxy, what happens to the stars, planets, and material that once orbited it? Could an entire galaxy be left without its gravitational anchor, slowly unraveling over time? Even more intriguingly, could these rogue black holes wandering through the cosmos be markers of ancient cosmic events that have reshaped the very fabric of the universe? Observing such movement also provides a unique window into the dynamics of extreme gravitational forces and the evolution of galaxies. With ongoing advancements in telescope technology and gravitational wave detectors, astronomers are determined to track and study these nomadic giants, hoping to piece together the cosmic puzzle of their journeys. As we ponder the immense forces at play, one thing becomes clear: supermassive black holes are not merely stationary powerhouses but dynamic participants in the grand ballet of the cosmos. And while this one drifts through the infinite void, it reminds us just how much there is left to uncover. With that thought in mind, let us now venture further into the unknown, where even more curious and unexplained phenomena await discovery. Turning our attention to one of the most perplexing enigmas of the universe, we delve into the mysterious presence of dark matter. To set the stage, dark matter is an invisible substance that neither emits nor absorbs light, yet its gravitational influence reveals its existence. It is estimated to make up about 85% of the matter in the universe, but the astonishing truth is that we still have no concrete idea of what it actually is. Scientists have observed its effects indirectly, such as the way galaxies rotate. According to the laws of physics, galaxies should fly apart based on their visible mass and speed of rotation. Yet something unseen, something incredibly massive, is holding them together. This unseen force is what we now call dark matter. The gravitational lensing effect, where light from distant stars bends around invisible mass, provides another compelling clue to its presence. Despite these observations, the direct detection of dark matter has remained one of the most elusive goals in physics. Recent experiments are pushing the boundaries of our understanding. Underground laboratories, shielded from cosmic rays, are equipped with highly sensitive detectors designed to catch the rare interaction of dark matter particles with ordinary matter. Meanwhile, particle accelerators are probing the subatomic realm, aiming to produce the theoretical particles that might explain this cosmic puzzle. The most popular candidates for dark matter particles are known as weakly interacting massive particles. These hypothetical particles could interact so weakly with ordinary matter that they pass through almost everything, explaining why they are so hard to detect. Another intriguing possibility involves actions, extremely light particles that might make up the dark matter halo enveloping galaxies. Despite these efforts, not a single particle of dark matter has been directly observed, leaving us with more questions than answers. Why is dark matter so abundant and yet so hidden? Could it be something even stranger, like primordial black holes or an entirely unknown form of matter beyond our current physics? The implications of solving this mystery are profound. Understanding dark matter is not just a quest for knowledge, it is a key to unlocking the very structure of the universe. Its presence governs the formation of galaxies, the movement of stars, and perhaps even the fate of the cosmos itself. And while the search continues, each experiment and observation brings us one step closer to unveiling the truth about this invisible cornerstone of our universe. As we ponder the vast unknowns surrounding dark matter, let us journey onward to another cosmic phenomenon, where the laws of physics are tested in ways even more mind-bending. Now venturing into another extraordinary corner of the cosmos, we uncover the mystery of so-called impossible stars, celestial bodies that seem to defy the very rules of stellar physics. Among these are stars theorized to be composed of strange quark matter, an exotic form of matter believed to exist only under the most extreme conditions. To grasp why these stars are so exceptional, let us first consider what makes up a typical star. Most stars, like our Sun, are composed primarily of hydrogen and helium, undergoing nuclear fusion to produce energy. However, the impossible stars seem to follow a different set of rules entirely. Strange quark stars are a theoretical possibility that arises when ordinary matter is subjected to pressures so intense that protons and neutrons might break down into their most fundamental components, quarks. Under these extreme conditions, these quarks could rearrange into a new form of matter, creating a dense, stable configuration scientists refer to as strange quark matter. What makes these stars so bizarre is their density. A sugar cube-sized piece of matter from one of these stars could weigh more than 1 billion tons on Earth. Unlike conventional stars, which have structures governed by relatively well-understood forces, these strange stars challenge our understanding of how matter behaves at such extraordinary densities. Recent astronomical observations have hinted at the existence of these improbable entities. For instance, certain neutron stars' collapsed cores of massive stars appear to be too compact to align with current models of stellar physics. Could they actually be strange quark stars masquerading as neutron stars? This possibility has sparked a wave of excitement in the scientific community, as it opens a doorway to completely new physics. The discovery of such stars would not only deepen our understanding of matter at the smallest scales, but also provide insights into the conditions of the early universe, where extreme densities and exotic particles once dominated. However, detecting and confirming the existence of these stars remains a significant challenge. Their unique properties, such as their immense density and potential electromagnetic signatures, make them difficult to study with current technology. But with advancements in telescopes and detectors, astronomers are hopeful that the coming years will yield answers to this stellar enigma. The existence of these impossible stars reminds us that the universe often operates in ways that surpass our wildest expectations, constantly urging us to push the boundaries of science. And as we marvel at the mystery of strange stars, we turn our gaze to yet another cosmic phenomenon, a massive star that vanished without a trace, defying everything we thought we knew about how stars live and die. With the intrigue surrounding strange stars still fresh in our minds, we now approach a mystery that sounds straight out of a cosmic detective story: the sudden disappearance of a massive star without so much as a supernova to mark its passing. Typically, when a massive star reaches the end of its life, it goes out in a blaze of glory, exploding in a colossal event known as a supernova. This final act not only releases staggering amounts of energy, but also scatters elements into space, seeding the universe with the building blocks of new stars and planets. However, astronomers were left bewildered when they observed what seemed to be a massive star vanish entirely, as though it simply faded out of existence. This puzzling event unfolded in a distant galaxy, where scientists had been monitoring a star that was about 25 times more massive than our Sun. Such a colossal star was expected to end its life in one of the most spectacular supernovae ever witnessed. Yet, instead of erupting into a brilliant explosion, the star dimmed and then disappeared. No dramatic burst of light, no detectable shockwave, just a silent curtain call that defied all expectations. One leading explanation for this extraordinary phenomenon is that the star may have undergone what scientists call a direct collapse. This process occurs when a dying star's core becomes so densely packed that it succumbs to its own gravity, collapsing directly into a black hole without the explosive theatrics of a supernova. This idea is particularly intriguing because it suggests that some stars can bypass the usual explosive finale, leaving behind almost no trace of their existence. Another possibility is that the star's light was obscured by an unusual accumulation of interstellar dust or material surrounding it, although this seems less likely given the thorough observations conducted. The concept of a direct collapse into a black hole isn't just fascinating, it has profound implications for our understanding of stellar evolution and black hole formation. If such events are more common than previously thought, they could explain why we don't see as many supernovae as we'd expect based on the number of massive stars observed. Confirming this scenario, however, is no easy task. Detecting a black hole that has formed in this quiet, unassuming way requires advanced technology capable of picking up its subtle gravitational effects or faint X-ray emissions. Nonetheless, astronomers are optimistic that with the next generation of telescopes and observatories, more of these silent collapses might be uncovered. As we marvel at the audacity of a star vanishing into nothingness, it serves as yet another humbling reminder that the universe operates on a scale of mystery and wonder far beyond our current grasp. And speaking of mysteries, we now turn to an even more dramatic spectacle: the merging of neutron stars, where the cosmic clash of these dense objects not only reshapes the fabric of space-time, but also forges some of the universe's heaviest elements. Shifting our focus to an awe-inspiring cosmic event, let's explore the merging of neutron stars, a phenomenon that not only warps the very fabric of space-time, but also plays a crucial role in shaping the universe as we know it. Neutron stars, the incredibly dense remnants of massive stars, are already some of the most extreme objects in existence. Imagine a single teaspoon of their matter weighing as much as a mountain. Now envision two of these celestial titans spiraling toward each other in a breathtaking cosmic dance, their immense gravitational forces drawing them closer with every passing moment. As they collide, the energy released is no less than staggering. This violent union sends ripples through space-time itself, creating what scientists call gravitational waves, disturbances that were first predicted over a century ago, but only directly detected for the first time in recent years. These ripples are like faint echoes of cataclysmic events, traveling billions of light years to reach us, and their detection has revolutionized our understanding of the cosmos. But these events are more than just dazzling spectacles of physics. When neutron stars merge, the conditions are so extreme that they forge some of the heaviest elements in the universe, including gold, platinum, and uranium. In fact, much of the gold found on Earth likely originated in such collisions, making it possible to trace the wedding ring on your finger back to a cosmic event billions of years ago. Observing such mergers in real time has become one of the most exciting frontiers in astronomy. In one landmark event detected a few years ago, astronomers used gravitational wave observatories to locate a neutron star collision, enabling telescopes across the globe and even in space to study it in multiple wavelengths, from gamma rays to visible light. This groundbreaking observation not only confirmed theories about how heavy elements are created, but also allowed scientists to measure the universe's expansion rate with unprecedented precision. Each new detection offers fresh insights, helping us piece together the puzzle of how matter, energy, and even time behave under the most extreme conditions imaginable. The merging of neutron stars doesn't just reveal extraordinary physics. It reminds us that the universe itself is a master craftsman, forging the very elements that make life possible. From these cosmic collisions, we gain a deeper appreciation for how interconnected everything in the universe truly is. As this profound story unfolds, it's only fitting that we now turn to yet another cosmic enigma, the debate that surrounds the mysterious interstellar visitor, Oumuamua, and the lingering questions of whether it could be an alien probe or something entirely unexpected. Now turning to the next captivating mystery, let's delve into the story of Oumuamua, an enigmatic visitor from the depths of interstellar space that has left scientists puzzled since its discovery. In late 2017, astronomers using a telescope in Hawaii spotted what appeared to be an unusual object passing through our solar system, later named Oumuamua, which means scout or messenger in Hawaiian. Unlike anything observed before, this mysterious traveler was the first confirmed interstellar object, meaning it originated from outside our solar system. What makes Oumuamua so perplexing, however, is not just its origin but its bizarre characteristics. First, there's its elongated, cigar-like shape, which is unlike any known asteroid or comet. Measuring roughly 800 meters in length but only a fraction as wide, it resembles no celestial body we've ever studied. Some compared its shape to a pancake, while others likened it to a massive shard of rock. Yet, even stranger was its behavior. As it zipped past the sun, Oumuamua seemed to accelerate in a way that defied expectations. Normally, comets increase speed due to the release of gas or water vapor as they heat up, a process called outgassing. But no such activity was detected with Oumuamua. This unexplained boost in velocity led to speculation that it might be propelled by something else entirely, perhaps even a form of alien technology. Some researchers have entertained the possibility that Oumuamua could be an artificial construct like a solar sail, a thin, reflective structure driven by sunlight. This controversial idea sparked heated debates, with skeptics arguing that the object's motion could still be explained by natural phenomena we don't yet fully understand. So far, no definitive evidence has emerged to confirm either theory, leaving Oumuamua's true nature shrouded in mystery. Adding to the intrigue is the fact that Oumuamua is now long gone, having exited our solar system at incredible speed before telescopes could gather more detailed data. This fleeting encounter has left astronomers with more questions than answers. Was Oumuamua a peculiar fragment of a larger interstellar body, shaped by billions of years of cosmic forces, or could it truly be a relic of advanced alien technology, as some suggest? As researchers continue to analyze the limited data collected, Oumuamua serves as a reminder of just how little we know about the universe beyond our solar system. Its appearance has inspired new strategies for detecting and studying future interstellar visitors, with hopes that the next one might provide clearer answers. And just as we ponder the mysteries hidden in objects that pass through our cosmic neighborhood, let's now turn our gaze back to the Sun itself, where shifting magnetic poles reveal yet another fascinating aspect of our ever-changing universe. As we shift our focus to the heart of our solar system, an extraordinary phenomenon is unfolding on the Sun itself. Its magnetic poles are wandering in ways we've never seen before. To understand why this is so remarkable, let's start with a simple fact. The Sun's magnetic field governs much of the activity we observe on its surface, from sunspots to massive solar flares. These magnetic poles, much like Earth's, are not fixed. Instead, they undergo a cycle, flipping positions roughly every 11 years. This regular solar cycle is driven by the Sun's internal dynamics, but recent observations suggest that something unusual is taking place. The poles are not just flipping, they're shifting in unpredictable ways, leading scientists to question whether our current models of the Sun's behavior are missing a crucial piece of the puzzle. So why does this matter to us here on Earth? The Sun's magnetic field directly influences solar storms, which are bursts of charged particles released into space. When these particles collide with Earth's magnetic field, they can create stunning auroras, but they can also disrupt satellite operations, power grids, and even communication systems. The shifting poles could intensify these storms, increasing the frequency and strength of solar activity. In fact, some researchers believe this could signal a more chaotic period of solar weather, with potential implications for our technology-dependent world. But the effects could extend even further. The Sun's magnetic activity is also linked to cosmic radiation levels in our solar system, which means these changes might affect astronauts and space missions as well. Currently, scientists are working tirelessly to understand what's driving this magnetic pole wander. Using advanced spacecraft like the Parker Solar Probe, which is flying closer to the Sun than any mission before, researchers are gathering unprecedented data about the Sun's magnetic field. By studying how the magnetic field twists and moves, they hope to uncover the underlying forces behind these shifts. There's even speculation that these changes could hint at a deeper, long-term cycle in the Sun's behavior that we have yet to fully grasp. This ongoing investigation is a powerful reminder of how interconnected we are with our star. The Sun doesn't just provide light and warmth, it actively shapes the environment in which we live, often in ways we're only beginning to understand. As scientists push the boundaries of solar research, the hope is that we can not only predict the Sun's future behavior, but also protect ourselves from its more disruptive moods. And speaking of disruptions in the cosmos, let's journey now to a series of galactic collisions that are rewriting our understanding of how galaxies evolve and interact. Now turning to the vast and intricate dance of galaxies, a new chapter of cosmic wonder unfolds with the phenomenon of unusual galactic collisions. Picture this: colossal systems of stars, gas, and dark matter colliding in slow motion over millions of years, reshaping one another in extraordinary ways. These events are not rare in the universe, but certain recent discoveries have captured the attention of astronomers for their sheer peculiarity. One such case is ARP 194, a group of galaxies that appears to be connected by a stunning, luminous bridge of stars stretching across hundreds of thousands of light years. This bridge is a product of gravitational forces pulling material from the colliding galaxies, creating a visually breathtaking structure that challenges our understanding of how galaxies merge and interact. The process of a galactic collision is as dramatic as it sounds. When two or more galaxies come close enough, their mutual gravity begins to distort their shapes, pulling stars and gas into long, flowing tails or dense, swirling cores. Unlike collisions we imagine on Earth, stars within these galaxies rarely crash into each other due to the vast distances between them. Instead, the gas clouds within these galaxies collide and compress, triggering bursts of star formation in what astronomers call starburst regions. These regions shine brightly with the light of newly formed stars, marking the impact of the cosmic encounter. In some cases, the resulting galaxy takes on an entirely new form, such as the Cartwheel Galaxy, which resembles a cosmic ripple frozen in time, likely born from an ancient collision. What makes these events even more fascinating is the unexpected variety in their outcomes. For instance, the Antennae galaxies, a pair of colliding galaxies named for their long, curving tidal tails, showcase a chaotic yet mesmerizing scene of intermingling stars and gas. Meanwhile, the galaxy NGC 520 displays the appearance of two cosmic pancakes sliding past each other, with a dark lane of dust bisecting its structure. These unique formations are not just visually spectacular, they also provide crucial insights into the life cycles of galaxies. Observing these collisions helps scientists piece together how galaxies grow, evolve, and sometimes give rise to entirely new cosmic phenomena. Modern telescopes like the Hubble Space Telescope and the James Webb Space Telescope have been instrumental in capturing these awe-inspiring scenes in stunning detail. Through their lenses, we can witness the intricate interplay of gravity and energy, revealing cosmic stories unfolding across billions of years. These observations are more than just beautiful. They also allow researchers to test theories about dark matter, gravity, and the role of supermassive black holes in galactic evolution. As we marvel at the sheer scale and beauty of these galactic interactions, it becomes clear that the universe is a place of constant change and creativity. These collisions, though violent on a cosmic scale, are vital for recycling and redistributing the raw materials of the cosmos, paving the way for new stars, planets, and even life to form. But as we leave behind these colossal clashes, let's journey now to a newly found nebula whose peculiar appearance and unexpected formation are sparking fresh debates among astronomers. Stepping into the kaleidoscope of cosmic phenomena, we find ourselves captivated by the enigmatic birth of a new nebula, a spectacle that defies conventional expectations. Nebulae, often described as the cradles of stars, are vast clouds of gas and dust that shape the universe's narrative of creation and destruction. Yet, every so often, a nebula appears in a form so unexpected and puzzling that it challenges our understanding of stellar life cycles. One such recent discovery is the Blue Ring Nebula, an extraordinary structure unlike anything seen before. Discovered by accident using an ultraviolet space telescope, this nebula features a luminous ring of glowing gas surrounding a faint central star, with a mysterious second ring only visible from ultraviolet light. Scientists believe it may be the aftermath of two stars merging into one, a phenomenon rarely observed and still not fully understood. This nebula not only intrigues us with its unparalleled beauty, but also serves as a clue into the dramatic lives of stars and their explosive endings. Nebula formation, in its essence, is a byproduct of stellar evolution. When massive stars exhaust their fuel, they end their lives in a final, dramatic act, ejecting their outer layers into space and leaving behind a core that becomes a neutron star or black hole. The expelled material spreads out, creating the delicate, glowing clouds we call nebulae. However, the universe never fails to surprise us with formations that defy this traditional script. Another stunning example is the Necklace Nebula, a planetary nebula formed by a dying star that expelled its outer layers while orbiting closely with a companion star. The result is a mesmerizing structure resembling a beaded necklace with glowing knots of gas forming the jewels. These peculiar shapes and compositions stretch the boundaries of what we thought we knew, offering glimpses into the chaotic and beautiful interactions between stars in their final act. One particularly bizarre case is the Red Square Nebula, an almost perfect square-shaped formation discovered near a dying binary star system. Its symmetry and sharp angles are nearly unprecedented in the universe, where chaotic forces often create more irregular or circular structures. The Red Square leaves scientists debating its origins, with theories ranging from overlapping outflows of gas to rare geometric alignments. Similarly, the Boomerang Nebula continues to baffle astronomers as the coldest natural place in the known universe, with a temperature even lower than the background radiation left over from the Big Bang. These examples show that nebulae are far from simple. They are complex laboratories where the physics of gases, light, and gravity intertwine in ways we are only beginning to grasp. Beyond their visual marvel, these nebulae are crucial to our deeper understanding of the cosmos. They are not just remnants of stellar death, but also the birthplace of new stars and planets. The materials they scatter into the galaxy, carbon, oxygen, and other elements forged during a star's life, become the building blocks of future worlds. Observing these unexpected formations allows scientists to refine their models of how stars evolve, die, and sometimes interact with their surroundings in unforeseen ways. Each new nebula discovered is not just a window into the past of an individual star, but also a chapter in the ongoing story of cosmic recycling, where the death of one star lays the groundwork for new beginnings. As we unravel the mysteries behind these vibrant clouds, it becomes evident that nebulae are not only monuments to the life and death of stars, but also a source of endless curiosity about the mechanics of our universe. With each revelation, we are reminded of the intricate beauty and unpredictability that defines the cosmos. Speaking of unpredictable mysteries, let us now explore a celestial phenomenon that has astronomers scratching their heads. A star whose mysterious dimming has sparked theories ranging from natural obscurations to the possibility of alien megastructures. With the next phase of the journey in sight, we turn our focus to a star whose enigmatic behavior has left scientists both intrigued and perplexed. Known as Tabby's star, or more formally as KIC 8462852, this celestial object has defied explanation with its baffling pattern of dimming and brightening. Discovered through observations from a planet hunting mission, Tabby's star exhibits irregular dips in brightness, some as significant as 20%, a phenomenon never before documented in such a star. What makes it even stranger is the lack of a clear pattern to these fluctuations, setting it apart from the regular dimming caused by orbiting planets or eclipsing stars. Theories abound as researchers attempt to unravel the mystery. One of the most fascinating and controversial ideas is the possibility of an alien megastructure, perhaps a massive energy harvesting device constructed by an advanced extraterrestrial civilization. Though speculative, this theory captured both scientific and public imagination, sparking debates and further investigations. However, more grounded explanations suggest natural phenomena like swarms of comets, asteroid fragments, or clouds of interstellar dust could be responsible for blocking the star's light. Some researchers even propose that the star's own behavior, such as changes in its outer layers, might play a role. Despite extensive studies, including analyses of data spanning decades, no single theory has yet accounted for all aspects of Tabby's star's peculiar dimming. The mystery deepens as similar dimming patterns are being observed in other stars, indicating that this might not be an isolated case but part of a larger, yet to be understood cosmic phenomenon. This enigma reminds us how much we still have to learn about the universe and the forces that shape it. As we leave behind the flickering light of Tabby's star, let us journey forward into the depths of the cosmos to uncover another celestial puzzle: the enduring quest to understand dark energy, the mysterious force driving the universe's accelerating expansion. Now venturing into one of the most profound mysteries of the universe, we encounter the elusive and enigmatic force known as dark energy. This invisible phenomenon is believed to be the driving factor behind the accelerated expansion of the universe, a discovery that stunned scientists in the late 1990s and continues to challenge our understanding of cosmology. Imagine this: instead of the universe's growth slowing down due to gravity, as once thought, it is speeding up, stretching the fabric of space itself at an ever-increasing rate. Scientists estimate that dark energy accounts for nearly 70% of the universe, yet its nature remains one of the greatest unsolved puzzles in physics. To uncover its secrets, researchers rely on some of the most advanced tools ever created. Space-based telescopes, like the recently launched missions dedicated to cosmological research, are designed to measure subtle shifts in the light from distant galaxies. These tools allow scientists to map the distribution of galaxies and detect patterns in their movement, revealing clues about how dark energy influences the large-scale structure of the cosmos. Groundbreaking surveys, such as those studying supernova explosions of dying stars that serve as cosmic markers, provide further insight into how the expansion rate has changed over billions of years. Despite these advances, countless questions persist. Some theories propose that dark energy might be an inherent property of space itself, described as a cosmological constant, while others suggest it could be a dynamic field that evolves over time. Still, other researchers entertain the possibility that our very understanding of gravity may need revision. Testing these ideas requires ever more precise measurements and innovative thinking, pushing the limits of both technology and imagination. It is a humbling reminder of how much lies beyond our grasp and how the cosmos continually challenges us to rethink what we know. As we marvel at the vastness of this unknown force, our journey takes us to yet another celestial enigma: bizarre exoplanetary systems defying the norms of planet formation and reshaping our perspective on the diversity of worlds beyond our solar system. Turning our gaze now to the extraordinary phenomenon of exoplanets forming in the most unexpected locations, we uncover a realm of cosmic creativity that challenges everything we thought we knew about planetary formation. Traditionally, planets were believed to form within the relatively calm and orderly confines of a protoplanetary disk, a thick, swirling accumulation of gas and dust encircling a young star. This neat model seemed to explain the structure of our own solar system and many others. However, recent discoveries of bizarre exoplanetary systems have completely upended this once straightforward picture. Astronomers have identified planets orbiting perilously close to their host stars, where temperatures soar to unimaginable levels, and others drifting so far away that they seem impossibly detached from the star's gravitational pull. These so-called hot Jupiters, for instance gas giants located surprisingly near their stars, defy conventional models of planet formation, which suggest such massive planets should only exist in the distant outer reaches of their systems. Even stranger are planets found within binary star systems, where the gravitational tug of war between two suns would seem to make stable planetary orbits unlikely, yet somehow these worlds persist. Adding to the intrigue, researchers have also discovered exoplanets in the most hostile environments, such as densely packed star clusters or even the chaotic aftermath of stellar collisions. These findings have revealed that the universe has far more ways of assembling planets than we ever imagined. Some theories suggest that rogue planets, worlds untethered to any star, might have formed in such chaotic settings before being ejected into interstellar space. Other models propose that gravitational interactions, such as with passing stars or other planets, may have pushed these worlds into their peculiar orbits over time. By studying these unusual cases, scientists are expanding our understanding of planetary science and uncovering new clues about the processes that shape worlds across the galaxy. The diversity of these systems not only underscores the sheer unpredictability of the cosmos, but also opens up tantalizing questions about the potential for unique environments and perhaps even conditions hospitable for life. As we ponder the remarkable adaptability of planets to form and exist in such extraordinary settings, our journey through the strange and wonderful phenomena of the universe brings us next to the detection of complex molecules thriving in environments once thought utterly inhospitable. As we venture further into the cosmos, an even more astonishing discovery awaits us: the detection of complex organic molecules in the most extreme and unlikely environments. These molecules, often referred to as the building blocks of life, have been found thriving in places that at first glance seem utterly inhospitable to any kind of chemical complexity. Imagine the crushing atmospheres of gas giants, where pressures and temperatures reach unimaginable extremes, or the icy depths of distant comets, where conditions appear far too cold and barren to support intricate molecular processes. Yet, against all odds, astronomers have identified compounds such as amino acids and hydrocarbons in these harsh settings. These discoveries have been made possible by advanced tools like spectroscopic analysis, which allows scientists to read the light signatures of these molecules from millions or even billions of miles away. Take, for instance, the recent identification of organic compounds in the dense, stormy atmospheres of planets like Jupiter or Saturn. These findings suggest that even in environments dominated by chaos and turbulence, nature finds a way to forge complex chemical structures. Similarly, icy comets, often dismissed as mere frozen relics of the early solar system, have revealed traces of life-essential molecules. When these comets approach a star, their icy surfaces vaporize, releasing gases that can be studied in detail. This has led to the detection of molecules like formaldehyde and methyl cyanide, precursors to amino acids, on comets such as 67P, raising questions about their role in delivering life-building materials to planets like our own. Beyond our solar system, the atmospheres of distant exoplanets have also yielded evidence of complex molecules, sparking speculation about whether similar processes could occur in alien systems. These remarkable findings challenge our assumptions about where the ingredients for life can emerge and point to the possibility that the seeds of life might not be as rare as once thought. By uncovering chemistry in such hostile environments, scientists are not only expanding the boundaries of planetary science, but also deepening the search for life in the universe. After all, if these essential molecules can form in the most unforgiving corners of the cosmos, who is to say what other surprises might await us? As we reflect on the uncanny resilience of life's building blocks, our next stop takes us even closer to the edge of the unknown, exploring how time itself behaves in the shadow of a black hole. With the next phase of the journey in sight, we dive into one of the cosmos' most mind-bending phenomena: the strange distortion of time near black holes, often referred to as time dilation. Picture this: close to a black hole's event horizon, time doesn't behave as we experience it here on Earth. Instead, it stretches, slows, and warps due to the immense gravitational pull of these celestial giants. This phenomenon, predicted by Einstein's theory of general relativity, is not just theoretical anymore. Observations have provided astonishing evidence of this cosmic time warping in action. For instance, astronomers have studied stars and gas clouds spiraling perilously close to black holes. They notice that as these objects approach the event horizon, Their movement appears to slow down dramatically when viewed from a distance, almost as if they're frozen in time. And yet, for those hypothetical observers near the event horizon, time would feel completely normal, a baffling contradiction that challenges our very understanding of how time works. Recent studies have gone even further to confirm these predictions. In one case, using high-precision instruments, scientists observed a star orbiting Sagittarius A, the supermassive black hole at the center of our galaxy. As the star completed its closest approach, the light it emitted shifted to longer wavelengths, a phenomenon called gravitational redshift, which is another indicator of time dilation. But here's where things get even more intriguing. New observations sometimes reveal behaviors that don't entirely align with our theoretical predictions. For instance, certain black hole systems exhibit variations in time signatures that raise questions about the fundamental mechanics at play, hinting that there might be nuances we've yet to understand. Beyond the scientific wonder, the implications of time dilation are profound. It forces us to rethink time itself not as an absolute, universal constant, but as something fluid and relative, deeply tied to gravity and motion. Imagine future space travelers venturing near a black hole. Their one-year journey might translate to decades or even centuries passing for those left behind. It's a concept that, while awe-inspiring, also blurs the line between science fiction and future possibility. As we stand on the brink of unraveling these cosmic puzzles, one thing is clear. Black holes are not just objects of destruction, but are gateways to understanding the deepest laws of the universe. And just as the mysteries of time around these enigmatic entities leave us spellbound, our next cosmic marvel brings another twist, taking us into the heart of a star cluster that seems to have sprung into being almost out of nowhere. Shifting our focus to the next cosmic wonder, scientists were recently astonished by the sudden emergence of a new star cluster in an area where such activity was least expected. Star clusters, which are groups of stars bound together by gravity, typically form in regions rich with gas and dust, the raw materials for star formation. However, this particular cluster appeared in a relatively barren region of space, perplexing astronomers and challenging long-held theories about the environments necessary for stars to be born. Through advanced telescopes and imaging technologies, researchers observed this cluster springing to life, with young, luminous stars shining brightly against their contrasting backdrop. Such observations are more than just spectacular. They offer critical insights into the mechanisms of star formation, forcing scientists to revisit and refine their existing models. For instance, some theories now suggest that galactic interactions or hidden reservoirs of gas could ignite the star-forming process in unexpected places. Even more fascinating, the stars in this cluster appear to be unusually massive and tightly packed, raising questions about the conditions under which they formed. Could powerful gravitational forces or previously undetected phenomena be at play? The answers remain elusive, but each discovery like this brings us closer to understanding the intricate processes that govern the cosmos. As we marvel at the vibrant birth of this unexpected cluster, it reminds us that the universe is full of surprises, constantly rewriting the rules we thought we understood. And while the stars in this newly formed cluster dazzle us from afar, another cosmic marvel awaits, one that flickers unpredictably in the vastness of space, leaving scientists puzzled about its true nature. Now turning to another cosmic enigma, we find ourselves captivated by the peculiar flickering of quasars, one of the most mysterious phenomena in the universe. Quasars are incredibly luminous objects powered by supermassive black holes at the centers of distant galaxies. As matter spirals into these black holes, it heats up and emits staggering amounts of energy, making quasars some of the brightest and most energetic objects in the cosmos. Yet, despite their brilliance, certain quasars have been behaving in ways that defy explanation. Astronomers have observed instances where these celestial giants suddenly dim, brighten, or even seem to momentarily vanish. What could cause such abrupt and unpredictable changes? One leading theory suggests that the flickering might be linked to variations in the flow of matter into the black hole, known as the accretion disk. Shifts in this disk structure or material density could temporarily alter the energy being emitted. Alternatively, large clouds of interstellar dust might occasionally obscure our view of the quasar, creating the illusion of a sudden dimming or disappearance. However, some cases remain unexplained even after accounting for these factors. Adding to the intrigue, the timescale of these changes is astonishingly short by cosmic standards, often occurring over just days or weeks. This rapid variability challenges our understanding of how such massive and remote systems operate. Could it hint at entirely new physical processes near black holes, or perhaps interactions with unseen forces in the surrounding environment? These unexpected fluctuations remind us that even the brightest objects in the universe can still harbor untold secrets. And as these quasars flicker unpredictably across the sky, another cosmic mystery quietly unfolds, a hidden realm of ghostly galaxies that stretches the limits of our understanding. As our journey through the cosmos continues, we venture into the hauntingly mysterious world of phantom galaxies, ultra-diffuse galaxies that challenge everything we thought we knew about cosmic formation. Unlike the familiar dazzling spiral or elliptical galaxies filled with stars, these ghostly galaxies appear almost invisible, cloaked in darkness and consisting predominantly of dark matter. What makes them so puzzling is their lack of luminous stars, with only a faint scattering of light scattered across their expansive forms, detected largely through their gravitational effects. These dim and elusive galaxies stretch the limits of our astronomical instruments, making them incredibly difficult to find and study. One groundbreaking discovery revealed a galaxy so diffuse it seemed to defy the rules of galaxy formation. Its stars were faint and thinly spread, and yet the galaxy still held itself together with the help of an immense dark matter halo. Such findings raise profound questions. How do these galaxies form in such sparse conditions? Did they once have more stars that were somehow stripped away, or are they products of unique and unknown processes? Some researchers speculate that interactions with more massive galaxies might have gravitationally disrupted their star formation, leaving behind these faint shadows of once thriving systems. Others suggest that their dark matter halos could be unusually massive and stable, allowing these galaxies to exist as faint relics in the vastness of space. Adding to the intrigue, phantom galaxies push the boundaries of our understanding of dark matter itself, the mysterious and invisible substance thought to make up most of the universe's mass. If these galaxies are indeed held together by dark matter alone, they may offer rare opportunities to study its properties in isolation, shedding light on this elusive force that shapes the cosmos. But for every answer, new mysteries arise. The detection of these ghostly galaxies has opened a door to an unseen domain, reminding us that the universe is not always as it appears. And as we gaze deeper into the void, one cannot help but wonder what other marvels might be lurking in the shadows, waiting to be uncovered. As we bring our exploration of the cosmos to a close, it is impossible not to marvel at the vast tapestry of mysteries we've uncovered. From enigmatic radio signals that echo across the universe, to rogue planets defying the rules of planetary systems, to the shadowy presence of phantom galaxies, each phenomenon reveals just how little we truly understand about the complexities of the universe. And yet, it is this very unpredictability that captivates our imagination and drives our relentless curiosity. The cosmos reminds us of one simple truth: there is always more to discover, more questions to ask, and more answers waiting to be found. So, what might still be out there, hidden in the void, waiting for us to uncover its secrets? What new wonders could redefine everything we think we know? We would love to hear your favorite cosmic event from this video, or even your own theories about these fascinating mysteries in the comments below. If you enjoyed this journey through the bizarre and breathtaking events happening in the cosmos, be sure to like this video, subscribe to our channel, and hit the notification bell so you never miss an update. Let's continue to explore the universe together, one mystery at a time.